All right, good morning, everyone. Hello and welcome to the final webinar, Webinar 5 in the Work Zone Traffic Control and Safety Series. My name is Paula Hyman from the Ohio LTAP Center, and I'll be your technical support for today's webinar. Just a couple housekeeping items as usual. Use that questions pod throughout the presentation, and Ray will address your questions periodically. There are documents available for download in the handout section. If for some reason you're unable to download the handouts, after today's webinar, they will be emailed to you. The webinar is being recorded, and providing that the recording is successful, the YouTube links to all the sessions will be emailed to all participants and uploaded to our LTAP website. I want to thank you in advance for your participation. And with that, I'll pass things off to Ray Brushart, Program Manager and Safety Circuit Writer with the Ohio LTAP Center. Ray?
Okay, good morning, everybody. Wow, we've made it to part 5 of this series. How could it be part 5 already? I mean, it just seemed like it was part 1 yesterday, doesn't it? Well, anyway, so we've talked about a lot of stuff from parts 1 through parts 4. Gosh, what have we gone over? We've gone over, first of all, a lot of general items about work zone traffic control, like where do we find the information on how to do it? And that's we learned about the part 6 of the Ohio Manual of Uniform Traffic Control Devices, which is also called the Temporary Traffic Control Manual, right? And showed you how to get your own copy of it, your own physical copy, by contacting the ODOT Office of Contracts, or you can view it anytime you want to online for free through either the ODOT website or through the Ohio LTAP website under our resources button. And what else? We gave you a PDF of the guidelines for traffic control in work zones. It's in your handout box. And you can also find that under resources on our LTAP page. Plus, you'll also find it as an app. You can, of course, I heard that it's not there right now, but it will be very soon. We have a person working on that to reinstate it under Google Play. But it could also, you can also find it on the App Store or whatever it is for Apple. If you just look for, I always just typed in Ohio Work Zone, and it would find it under that way. But for some reason it was taken down, but they will have it reinstated soon. So that's a free app, and it's identical to the guidelines for traffic control in work zones that you have as a PDF, but it's nice to have it on your phone as an app. And so we also talked about, you know, how to make our work zones as safe as possible. We learned about standards and guidance and options that's discussed in each of the 46 different typical applications. And we went over different scenarios for lane closures on different types of roads. And we went over flagging in our last session. And now today we're going to talk about mobile operations and then street closures. And then we'll have some time left over to go over some exercises. I'll give you some scenarios, and then you can tell me how you would set up a work zone to handle that situation. So let's go ahead and get started then with our lesson 6 here, which is mobile operations. So you can see there's a picture of a guy with his he's filling potholes with his sprayer, and that's of course a typical work zone for this time of year, as we have lots of potholes develop because of the freezing and thawing. And so it's if you take away anything from this class, is that we want you to think about how you're going to set up your work zone and have a plan in mind before you even leave the garage that morning. So we'll give you some tips and tricks when we get to the exercise portion of today's lesson on quick ways. I mean, 10 minutes or less to figure out how you're setting up your work zone, just a step-by-step process on how to do that. Because we definitely don't want you to just jump in the truck and go out there and you have it in your mind that you're going to wing it once you get out there. So let's go ahead and begin with mobile operations. So moving and mobile operations, I'm thinking that, didn't we go over this in part forward? It seemed like I just talked about this stuff. So maybe we're supposed to begin with street closures today, aren't we? Say I had some deja vu there. So let's begin with talking about street closures today. So yeah, we went over all the mobile operation stuff in our last session. We went over all the different typical applications that dealt with mobile operations, whether you're on the shoulder, which is part 4, or typical application number 4 or 6. And then on a 2-lane road, we use typical application 17, and multiple lane roads was typical application 35. Okay, now I got it. I'm getting it now. So lesson 7 is street closure. So let's talk about the proper ways to close a street down. So street closures, a little bit about them. The public relies on the proper traffic control when we close a street down, and they need to understand how to get to where they're going with that street closed. They need to how to they need guidance for this. We don't want to leave drivers confused or inconvenienced. And sometimes we need to set up a detour when we close a street. Sometimes it's not obvious how they can get from point A to point B with that particular street closed. So traffic control is very important, even at low speeds. And drivers and other users like pedestrians and bicyclists and big trucks, they need to know their options, because big trucks can't always use every street, right? There's even signs sometimes that say no trucks. So sometimes we have to close down a street without notice to the public. So this is common during emergency situations. I'm pretty sure this time of year you've maybe had to handle some emergency situations that deal with flooding or even washouts. And in these situations, law enforcement has the authority. Sometimes they need to set up their vehicles in certain locations with their lights on to let people know not to use that street. And they'll do that until you can help them with the proper road closure devices. And then we have planned road closures. Maybe there's a project in place where we have to close a street to get the work done. And to do that, you need to consult with the authorities who own that road, whether it be a county road where you need to get that approved by the county engineer or city engineer, or maybe the township trustees. So a permit is needed, and usually a permit is based upon an approved plan of some sort. And maybe you have to install some regulatory signs, which also need to be approved. So we have 4 types of street closures. There's an emergency street closure, or short-term, or long-term, or special events. Sometimes, of course, in Ohio, in our cities, we have a lot of special events, whether it be a 4th of July celebration or a festival of some kind. During those events, we have to close streets down and put in detours. And as volumes and street size increase, so does the planning and traffic control required. So let's talk about emergency road closures first. In these situations, there's no time to preview the site. You may have to improvise with available devices. Visibility, warning, and control are important, and we discussed that in previous lessons. And we'll need to call for more equipment and replace temporary measures as soon as possible. Then we have our short-term road closures. So these are planned events, typically during daytime operations of 12 hours or less. And typically the workers are present from the setup all the way through to reopening the road. And so in these situations, we obtain a permit from the local road authorities, Or, maybe you're a worker for that city or village or county engineer, and that, you're just following orders at that point. You don't need your permit because you are part of the people that own that road. And we have to follow all official regulations, preview the site, lay out a diagram of traffic patterns and your traffic control, your maintenance of traffic plan, and you're deciding on what temporary traffic control equipment and control you'll be using. So we want to analyze all of our options and select the most appropriate devices, which of course means our warning signs, whether we're going to use cones or drums or barricades with warning lights. And it says use common sense. Usually the workers are very familiar with their different streets and the different areas and what sort of measures they need to put into place so that the motorists know what to do. So visibility is key. If we're on a residential street with low volume, maybe all we need are some cones, and a detour is probably not needed. And if poor visibility or obstructions, you may need to add additional advanced warning signs. For our higher speed and higher volume streets, we need to add more control, we have to add some advanced warning signs and more traffic control equipment, and a detour may be required. So as we set up a detour, we've already checked with local authorities and they've authorized it. And maybe we need to notify emergency services depending on how long of an event this will be. And we need to clearly mark the new route with signs. And it says to refer to the OMUTCD Part 6, the Temporary Traffic Control Manual, because as you may have guessed, there are several typical applications regarding detours. So our typical applications really help you out with the proper signage and temporary traffic control devices. So here, for instance, on the screen is typical application number 19. As you can see, it looks like it's in a city or village, and it's called Detour for One Travel Direction. So as you can see on the right side of the page, we're closing one lane on looks like a major 2-lane roadway, or maybe it's a multiple lane road and we're closing both southbound directions, both southbound lanes. And so the only lanes open are for northbound in this case. So we need to handle the southbound traffic. And so as you can see, as they approach this, they see the advanced warning sign, road closed ahead, detour ahead, and then they have the barricade here. And on that barricade, as you can see, is a sign that says the name of the street and it's closed, Main Street closed or whatever, and a detour sign. So the detour is pointing them this direction. And as they get to the next block or wherever the detour takes them, they'll have a sign there that says Main Street Detour, and it's an orange sign. And also this direction has a sign that says Main Street is closed and there's a detour. So we're sending them this way. And then the next sign they see, they have to pass, maybe they have to pass some streets that have barricades on them until they get to this point where we're going to have them turn left. And it has the sign Main Street Detour with the arrow pointing this way. And then it has another sign here which lets them know that they'll turn right, and then that's the end of the detour. So there's also a notes page on this to discuss different scenarios and different standards, guidance, and options to enhance that. Then we have typical application number 20 is where we have the detour for a closed street. So both directions are closed in this case. And so we have to make sure that the signs are correct in both directions to get them around this closed street. So we're going to have similar signage for 19 for the southbound traffic, and then we're going to have pretty much the same signage, but different direction to get them around it for the northbound traffic. So you're really guiding them through at each intersection that they arrive at to let them know that they need to turn. So clear guidance is important. And then typical application number 28 deals with a sidewalk detour or diversion. And the picture on the right shows us a diversion, and we actually had a webinar on this about a month ago with Ron Eck from West Virginia University, talk about how to handle maintenance of traffic for pedestrians and also with ADA requirements. And so he used this typical application quite a bit, especially in the design of the diversion here for pedestrians and also people with disabilities. And then over here on the left, they have not only the diversion, but also when it's closed. So if it's closed and we need a detour, there is no diversion. So we need to get the pedestrians around it by crossing the street. So we need to have these proper signs that are listed here. So there is a proper method of installing and removing all of our devices. And we do this in the opposite manner of lane closure. So we install our devices, our signs, and especially our signs against the flow of traffic, and then we remove them with the flow of traffic. So here's, if we take a look at typical application number 20, what would be the first signs that we would install? Once you write your answers in either the question or chat box, what signs would you install first? Let's see what we have here. Detour road closed ahead. Okay. Road closure ahead. So that's, if you say ahead, that is the advanced warning area. Oops. Whoops. I keep hitting the wrong buttons. Okay, so we're going to install against the flow of traffic. So if we're installing them with the flow of traffic, that would mean that wouldn't that mean that we're going to install the detour first and the barricades first? Let's see. So first, locate and mark the detour sign positions and locate utilities of post-mounted devices. You always got to remember to call OOPS, right? I got to give a shout out to the OOPS people because they've really improved over the years about how quickly they can help you determine if it's a good location to install signs. So we begin the installation with the last sign in the detour series before establishing activity signing and placing devices. So the last sign in a detour, what is the last sign in a detour? So let's see what else we got here. If we look at the picture, the last signs would be, of course, in detour, wouldn't it? And of course, we want to, if there's a problem here, of course, we got to take care of the problem first, especially if it's an emergency situation like a washout. We want to make sure at least our barricades are up first. And then work backwards from there, because we're installing them against the flow of traffic. And then when we remove the detour signs, it says remove them downstream. So if we go, so that's with the flow of traffic. So it says always navigate from the public's point of view, check the fundamentals, and make sure you have clear visibility, proper warning, and proper control. Get this box out of my way. There we go. Long-term closures. So this is a type of project that is needed for major utility repairs or a road construction project, and it may stay in place for days, weeks, or months. So in that case, we're going to require larger, more stable devices like our Type 3 barricades, like you see in the picture. Barriers or fences if you're in a city or village or a central business district where you have pedestrian, or maybe close to a school or university. And communication and proper placement is essential. So in that case, that means you're going to have an approved maintenance of traffic plan. So that's usually reviewed by several people. Like besides the city engineer, maybe there's a traffic engineer or different utilities. Of course, if it's a utility project, you're going to have to make sure that everything is clear with them as well. So we need to cooperate with all the local authorities. Make sure when you are installing the approved signage that, as we discussed earlier, you want to install them in a way that the motorists can actually see those signs well, not place signs behind a pole or something. And you need to schedule inspections and make sure that everything is well documented. And you may present special problems to local traffic. So it says use the road closed to through traffic sign. And the longer the project, the more of a chance you are where people just get tired of it. They might try to violate it and drive through. So if there is a problem that would cause like a wreck or something, you really want to double up the devices so they really can't squeeze through there. I know that's what happened on down in Pike County on Germany Road, County Road 66. I know that closure's been there for 2 years, and sometimes people do their best to drive through it till they finally get all the way up there and realize that there's no way they can. But hopefully that project will come to an end this year at some point. In our long-term closures, we need to pay attention to hazards such as sidewalks that are out, material or equipment storage, excavations, piles of debris, and manholes. So that's especially if it's, in the long term, like I said, people might try to drive through there. They're tired of it. So we got to protect those people as well so they don't drive into something. So in those instances, we use highly visible hazard markers. And if it's long term, we shouldn't just use cones in front of the hazards. We should use the drums and barricades and install flashing warning lights on the type 3 barricades. And so as you inspect it, you're going to navigate through there. So we want you to drive through the detour and pretend that you are just someone from the public driving through, and make sure it actually makes sense, that you can actually drive the plan and adjust as needed. Of course, with necessary approvals, and document those changes. Then we have our special events, which are parades, marathons, games, social gatherings, races, festivals, things like that. So in these cases, we can count on police to help us with traffic control, and we may need to install traffic control devices. And of course, doing so, we follow the fundamentals of visibility, warning, and control, and check with local authorities. Visibility of workers is important. Make sure all the workers have the proper apparel on. Sometimes type 1 barricades are good for the lower volume streets, but type 3s are needed on your main roads. And of course, if it's going to be a nighttime event, it needs to be retro-reflectorized, or maybe even add some flashing lights to the barricades and signs. So it says, be familiar with the OMUTCD. I recommend that for everyone that has a job that working on the roadways. It's not just part 6, but there's 9 parts, so it's good to be familiar with other parts as well, like part 2, all the signs, part 3 for pavement markings, 4 for traffic signals. There's a part for school zones and railroad crossings. They all have their own regulations and standards that need to be followed. It's not just part 6. So in summary, again, we need to use our 3 fundamentals that most of these are always shown in the typical applications, but it's visibility, warning, and control. When we talk about visibility, it's the workers' apparel. Make sure they have the proper apparel on, and make sure the devices, they're not the old devices that are faded and non-retro reflective. We want you to use the new signs that do meet the standards for retro reflectivity and all of that. And the proper warning, I can't stress enough that we get our advanced warning area correct, as shown in the typical applications. Make sure we have, a lane closure usually has at least 3 advanced warning signs. And then, like we talked about in flagging, if we're on a typical 2-lane rural road in Ohio with 55-mile-per-hour traffic, we want you to use 4 advanced warning signs. That be prepared to stop sign can be added to your sign series. So, but especially when it comes to street closures, can't say enough how important it is to have good planning. So it's definitely more than just one person needed to plan a street closure. And so, properly trained workers and the proper devices and procedures. And again, it says common sense and judgment. So, engineering judgment is discussed quite often in the manual. And so that's why it usually takes a team to discuss these, to think about many different things when it comes to street closures and what's needed. Maybe not much is needed at all, again, for those low volume residential streets. But for your more important roadways, it takes more planning and thought about what would be the best way to close a street and what is the best detour and how to sign properly. Okay, do we have any questions on road closures or detours? Okay, well, let's go ahead and then we'll talk about, let's move to our design workshop. So we're gonna, let's see, I see a question maybe coming up. Okay, let's go over some situations, and I'll give you a situation and you tell me, first of all, what is the best typical application that we would base our work zone design upon for this situation. It's always important for you to begin the design process with that in mind. Whatever the situation is, and you know you need to set up a work zone, your first question you want to ask is, what would be the typical application that I base this on from the manual? You know, like I said, there's 46 different typical applications. So what I want you to do is pick one of those first, and then we'll go from there on the rest of the details. Okay, so again, this is our OMUTCD, and there's 9 parts, and we're dealing with part 6. So this is our manual that I'm talking about. Let's first talk about some rural situations. So on this layout here, if we were meeting in person, I actually have a big plastic tube that you roll out, and it looks like this picture, and we go over scenarios. You see all these different orange areas. Those are different workspaces in different rural locations. So we've got down here at the bottom of the page, we have a 2-lane curvy road with a workspace in it. We've got a rural 4-lane divided highway. We've got a rural freeway with 3 lanes in it. And we've got, you know, a workspace over here that's confined. It's on a bridge. And then we have an intersection. We've got near side of the intersection. We've got far side. We've got a question over here about what to do in the vicinity of a rural highway off-ramp. So we've got different locations. So let's pick one here. Let's pick the 2-lane. Let's don't do low volume. Let's do this one here. Let's do a curvy. Here we go. It says a flagging operation. So it says design a traffic control zone with the use of flaggers and corresponding advanced warning devices for a short duration stationary project, which entails bridge repair on a 2-lane rural highway. The horizontal and vertical curves limit the sight distance to less than 300 feet. The speed limit is 55, and the lane and shoulder widths are 12 and 6 feet respectively. So you have 12-foot lanes and 6-foot shoulders. Well, that's pretty good, right? In a lot of our 2-lane roadways, we don't hardly have any shoulder, maybe 2 feet at the most. So, but in this case, we have a 6-foot shoulder. So why don't you guys tell me, which typical application do we use? You can just use a number as the basis of our work zone design in this scenario. Then we'll ask more questions from there. Okay, I see some answers rolling in. All right. I see the answer 10. So yeah, typical application number 10 deals with flagging on a 2-lane road. So that is the typical application we use. Does everybody understand that much so far? And so the other design considerations we have in mind is we have a restricted sight distance. So what is the next really important thing we need to figure out? And that would be, where would the flaggers stand in both directions? Where would we place our flagger for this situation? So the workspace is here. We've got some curves, whether they're vertical curves or horizontal. Could be either. Well, we can see here in our plan elevation, you can see we have a dip in the road. So what do we have? We had some answers rolling in here. Here we go. Right, before both curves, that's the answer we want. So the flaggers need to stand before the curves in both directions. That way the motorists can see them. And so when we look at typical application number 10, can't stress enough the importance of, let me get this out of the way here, setting up our work zone properly. So when we look at typical application number 10, let's get up here. Let me find it in the manual real quick. 12. So here's number 10. I can zoom out so you can see the whole picture. So there's our, they draw typical application number 10 with a curve in it just to drive home the important point that the flagger needs to stand, as you see in this picture, before the curves. And then the final design element I want you to consider is, are these the only 3 signs that we use in this situation? So it's yes or no. And then if it's no, then what other sign would we need? How about that question? Okay, I see the answer here. Yes. So Brett tells us that we should be also use the be prepared to stop sign as well. So that's the correct answer. So this is a 55 mile per hour. That's high speed. That's the highest speed you can get legally on a 2-lane road in Ohio. And so we want you to, if you look at the notes page of this typical application, and it's clearly shown in 2 different areas to use the be prepared to stop sign, both there and under options. And so remember, when you see options, that's telling you how to make your work zone as safe as possible, especially in high speed areas, high speed and high volume and restricted sight distance areas. So very good. All right, so let's move on to our next scenario. So this question is pretty much about the same thing, about where to place the flaggers. This one actually gets more detailed about, let's see, it says design a traffic control zone with the use of flaggers for a work zone on a 2-lane rural highway with a vertical curve. The 85th percentile speed is 60. And the lane and shoulder widths are 11 and 6 feet respectively. Sight distances on the vertical curve are less than 300 feet. So, again, it's just basically making sure that you have your flagger standing before those curves. And then we have an intersection in a rural area. Let's check it out. So this is a little bit tougher for you. So it says design a traffic control zone with the use of flaggers for a work zone on a 2-lane rural highway at an intersection with a local stop controlled road. So that's an important element of this. It's a 2-way stop, not a 4-way stop. And as you can see where the work zones are located at this intersection. So on the east leg, it's it's near side for the east side and near side for the west bound. And the north and south are the stop controlled. So it's a 55-mile-per-hour situation. Lane and shoulder widths are 12 and 5 feet respectively. So again, the first question in any work zone design is which typical application do we use as the basis for our work zone design? So I want you to give me that answer first. And again, this is a situation where we're not going to find a typical application that looks identical to this. You would think that they would have one, right? But like I said, when we were talking about intersections, there's only about 7 or 8 intersection typical applications. So what you have to do is you have to modify. Remember, we talked about modifying typical applications. So this is one of those deals. So first, let's once you give me the answer about which one we use as the basis, and then we'll modify it from there. So if I look in questions, okay, I see someone wrote TA22, but that's not really correct. TA22 is an intersection job, but it's for a multiple lane roadway on the far side of an intersection. So we're dealing with a 2-lane road here. So it's going to be, the number that we're going to use is going to be smaller, it'll be lower than that. So we have to find one for well, actually, it's an intersection job. I just really confused you there, didn't I? It's not a lower number, but it's the number of lanes on the road are lower, but it's still an intersection. You're kind of close because at least you picked an intersection, but it's a different typical application that deals with an intersection because we're using flaggers. TA22 does not use flaggers. Okay, I see some more answers rolling in. They pick a number 27, and I believe that's the correct one. So let's check out 27, see what that is. If I get back to my manual, let's find 27 real quick. You can also use the PDF of the guidelines for traffic control and work zones in your handouts. So here's 26. They're not using flaggers here. Then we get to 27. Closure at the side of an intersection with flaggers. So yes, this is going to be the one we use. So as the basis. Now the difference is in this picture, the work zone is what they call at the side of an intersection. Of course, ours is going to be, we have two separate work areas. So this one would be pushed to the west in this area, and then there'd be another one over here. So it seems to be a matter of, and plus, this intersection is, it doesn't really even tell us, does it, about how each leg of the intersection is controlled, whether it be stop or not. So we have the benefit of knowing in our design problem that the north and south legs are stop controlled. So on this, in this scenario, they have a flagger on all four legs of the intersection, don't they? Or do they? As I'm zooming in here, I was trying, usually they have a red flag or something for the flag where the flagger's standing. But I mean, if you're traveling westbound in this picture, you see the three signs and the flagger, and then when they get here, apparently there's going to be, let's see what we have here. Okay, that's not the flagger, that's just a flag to draw attention to that. So there may be one or two flaggers in that scenario. So I guess that's part of the deal with that one. You have to figure out if you're going to use one or two or more flaggers and then where they're going to stand specifically. But that's what we use as our basis. And then there's a note page that goes with it. And it says the situation depicted can be simplified by closing one or more of the intersection approaches. If this cannot be done and or when capacity is a problem, through vehicular traffic should be directed to other roads or streets. And it also says, depending on road user conditions, flaggers or uniformed law enforcement officers should be used to direct road users within the intersection. So that's another thing about the manual. It tells us in several different areas that when we're working at an intersection to always consider law enforcement to help with the flagging or control at that location. All right, so let's get back to our problem with all this in mind. Let's see what we have here. So when we modify this, we're going to do it this way. So here's our solution. So on the east leg, we've got the, since it's high speed, they want us to use the be prepared to stop sign. So we have four signs and the flagger at this location. So the flagger on this leg is standing at the beginning of the cone taper. And then we have on the north leg, it's a stop controlled intersection. So they have to stop anyway. But they have a road work ahead sign followed by a flagger sign. And then the flagger is actually standing in the middle of the intersection. So we have one flagger here. And then where else? We also have a flagger here on the east leg and a flagger on the west leg. So before both workspaces are flaggers, and then the other flagger is in the center of the intersection. And so they're all going to be in communication with each other as to how they're going to, as to which leg has the right of way. And so that's how they've accomplished this. Okay, let's take a look at another one. We have, if we go back to our layout, we'd be looking at a rural 4-lane divided highway. and it's in the area of an off-ramp. So we have to close the right lane pretty much right at where the exit is. But it's not going all the way through. So we might be able to leave it open, don't you think? So we need to know how to do that. So the first question is, which typical application do we use as the basis of our design for this situation? It's going to be a high number because it's we're dealing with multiple lanes. So multiple lane situations begin with typical application 30 and end at 46. So somewhere between 30 and 46 would be the typical application we use. What do we have here? We see someone has answered with TA 42. So Sean's pretty quick at this game. Let's see what 42 looks like. So if I get back to my manual and I scroll down to 42, so here's 42. See what it looks like. Work in the vicinity of an exit ramp. Aha! Wow, look at that. So yeah, I think clearly this is the typical application that we would use, but it might be a tad different. Is it different? Well, we've got the difference is that we're on a 2-lane rural highway. And this looks like a freeway because it has 3 lanes going in each direction. So we need to modify it so that it's a 2-lane roadway. So we have our road work ahead. The second sign in this series says right lane closed ahead, and then a merging symbol sign, and then we have an arrow board, and then we have on the far side we have cones installed in a way that we have this it's called a theoretical gore area, and we have the exit ramp open signs. So we need to take that into consideration. So let's go back to our problem. And so I guess that's good news that we don't have 3 lanes, we only have 2. So we need to close the right lane. It's pretty much a right lane closure, a typical right lane closure like in TA 33, but then we have to enhance that with some more signs like exit ramp open ahead and exit ramp open, and then create that theoretical gore area. So let's we can get these boxes out of the way. So let's move on to again, there's our workspace, and then here's our solution. So we have our standard right lane closure signage package. Since it's a 2-lane divided highway, we put our signs on both sides of the road, and we see the length of our taper for 65 miles an hour is 780 feet, and shows the placement of the arrow panel. We have our sign here, it says exit open, it says optional, but since it's high speed, it means we really want to use it. There's our work area, and then we have, once we get past the work area, we see the exit sign clearly marked, and then we have, it shows the placement of our cones and drums, and then the end road work sign as well on both sides of the road once they get past it. So that's how we would do that. And then here's a picture of what that would look like in reality. So as you can see, they zoomed in on how the theoretical gore is created by the use of drums, which aid the driver in identifying the location of the exit. All right, let's get to a good one here. So here we have a workspace. Here's a freeway problem. So we have you see the workspace there. It takes up more than one lane, doesn't it? So we talked about the closure of multiple lanes, how to get that done. So let's see what the question says. It says, for the situation below, sketch the proper taper and buffer space required for the particular condition. So we need to figure out the proper taper, how long of a buffer space. We assume that the channelizing devices are used to outline the taper. Sketch the taper and buffer space, showing spacing, locations, and type and number of devices. See, we can get really detailed in our design here. Lanes are 12 foot wide as are most freeways. Close the right 2 lanes of a divided 6-lane highway. Speed limit's 55. So it must be in the vicinity of a city. As we approach, we usually lower the speed to 55. And the use of the shoulder would not be possible. The off-peak volumes are 1,100 vehicles per hour, or less than 1,100 vehicles per hour. Okay, so that sounds like a lot of things to sort through, but the first thing we want to do is determine which typical application to use. And so let's begin there. So can you tell me which typical application you would use to close 2 lanes of a multi-lane highway? All right, let's see here. TA 37 is close. Okay. All right, let's take a look at 37. So if we scroll back up, isn't this a fun game? Okay, so we have a multi-lane freeway. Okay, this one here has 4 lanes that they're necking down to 2. So yes, we'll use this one because it shows how to close 2 lanes down. So we can pretty much copy and paste that part, right? So we have our signage package has 2 right lanes closed in a half mile. Those are, first is the road work ahead. It's always road work ahead is the first sign. They're having it showing it this way because you look at these lines. These signs are on both sides of the road. Then the 2 right lanes closed ahead. Then the merging symbol sign. And then as you can see, with 2 lanes closed, you have an arrow board for each lane closure, and in between is a tangent space of twice the length of the merging taper. And then here's a buffer space. So it says optional, so that we're in high-speed traffic, so we want to use it. So we got the first part of the question done. So I think the next part was, let's go with how long of a buffer space do we use in this area? Let's see who can remember how to do that. I'm not going to give you any hints. You have 15 seconds. I hear someone wrote L. I want an exact number. You know the speed limit, so that was it's not half L. There's an actual place to go to find the length of a buffer space. Let's see here. I'm going to open up this PDF that's in your handout package. It says Work Zone Pocket Guide, optimized. So if you recall, a lot of the answers in the work zone design are in a table on page 17 of this handout. So here we are on page 17, and the speed limit is 55. So therefore, we look at the bottom table on page 17. It's titled Tapers and Flagger Station Distances. But as we take a closer look at this table on the far right, it says Flagger Station / buffer. So this is where we find the length of our buffer space. So if we look at our speed limit, which is 55, we look at the speed limit and go across to the buffer column. It says 495 feet. So that is the length of our buffer space, 495 feet, and that's based on what? Can you remember what the length of a buffer space is based upon? It's an engineering term. You got 10 seconds. And you can use initials if you want. There it is. Leonard and Brett are on it. Stopping sight distance. So the stopping sight distance for 55 miles an hour is 495 feet. Okay, so what's another question that they asked here? They want to know, sketch the taper. What's the taper length? So, and when I say what's the taper length, it's in the first, we're closing 2 lanes. How long is the taper at the first taper when we close the far right lane? So the length of that taper, we go back to our page 17. Let's see if someone got it here. 660 feet. We look at 55 and we go over to L, which is merging taper. That's this column here for merging taper. 660 feet. So that answer is correct. So if we go back to our typical application, we see that we have a merging taper here, length L, so that's 660. Then we have a tangent area, which is 2L, so that's going to be 1320. And then we have another L, so that's another 660 for this merging taper. And then the buffer space was 495 feet. So if I really wanted to get nitpicky in the design, how about this question? What is the minimum number of cones or drums needed in the merging taper? How can we determine that? There is a way. I'll let you look at that table on page 17 and see if you can figure it out. The minimum number of cones or drums in the merging taper. Okay, I'm zooming in on these boxes here on the right. This box here is titled maximum spacing of channelizing devices. So there's two types of roadways to concern yourself with. There's 2-lane roads and multi-lane roads. And we're dealing with a taper. Okay, who's got it? Let's see. I have Matthew has rung in first with 12. And that's very good, Matthew. But if I wanted to get, I got Amir with 15. But the way to figure this first taper, let me bring it back up. So this taper here, the very first one, the way to do that is take the spacing, it's the length, which is 660, divide it by the spacing requirements, which is the speed limit, so that's 55. And then the trick part of the question is to add 1, because the very first drum is going to go on the white edge line, and then you put your 12. So I'd say the answer is 13, but I got to give credit to Matthew for getting the best answer. Way to go, Matthew. And then Gary says 44, so I don't know. I was going with minimum number. So, but that's how you would calculate it, by using those tables on 17. So it's the length divided by the spacing requirement. And then let's also do let's do a extrapolate on that and say what's the minimum? This is going to be real tricky for you. What's the minimum number of drums throughout the buffer space? I'm not going to spend too much time. You got 25 seconds. Go. Okay, I see some answers rolling in. What do we got here? 16. I've got 7. I've got 8. I see 6. But he's worked it out. He's got 660 divided by 2 times 55. Some of those elements are correct, but remember, we're talking about buffer space, not the taper. So Leonard, you got the 660 is the length of the taper. I'm looking for buffer space. So it's kind of tricky. You gotta know what to look for. So let's walk through it here by looking at these tables. I say buffer space. The length of it is, we already determined that, is 495. And then we look at the spacing of the channelizing devices throughout the buffer. You have to look at this column. The third column in this table says buffer space and workspace. So it's got a different spacing, 2 times the speed limit, which some of you got right. So it's basically 495 divided by 110. So that came up 4.5. So might as well round it to 5. So that was the answer I was looking for. And again, that's the minimum number. Okay, you can put more in You can put them side by side if you want, but that's the minimum number. Okay. Okay, so I think we beat this problem to death. Let's move on to another problem here. Let's see here. So there's where they actually laid it out. Let's see here. Let's go to another one. I think we have some more. What's this one here? Okay. A lot of these are, I know what we can do. Let's just make a problem up. Remember, I told you we can use Google Maps to help us out in many ways as we set up our work zones. Let me see here. So if we go to Google Maps, come on, man. All right, let's see here. So here we go. We're in Ohio. What else does someone say here? Let's switch to our satellite view. You got to switch to satellite view. And we zoom in down here to we're zooming in on Columbus. So let's get a good situation here like you might find in your a typical maintenance situation. Let's say we got a problem down here at 3rd Street and Kossuth Street. This is like the German Village area. So we zoom in on this street here. See what we're dealing with. We got a 2-lane road, but then we can also look at specifics. If this little yellow man in the bottom right corner, if you click on him and drag him, you'll see if the blue lines light up, that means you got street view. So this really helps out as well in designing a work zone, because you get down here and you're on the street, so you know the details of what you have as far as the number of lanes, and is there places where you can good places to put your signs. Like it's always good to have a tree lawn between the sidewalk and the curb. It's always good areas to put signs. Or you can cone off. If there's parking, you can put several cones to make sure no one pulls into there. You can put signs in this area so they stick out better when you're at the intersection. So I was wanting to get a multiple lane road situation here, but let's go over to High Street. So here's High Street. Let's say we're at Columbus and High Street. And let's go mid-block. Let's say there's a big pothole right here. And it's not just a regular pothole. It requires a fix that's going to take us 3 hours to get done. Okay, so if I zoom out, we see we're in between Frankfurt Street and Columbus Street. We're closer to Frankfurt, about 3/4 of the way there. And it's in the right lane, northbound right lane. This is a 4-lane undivided roadway. We can drop our little man down here. We can see what we're talking about here. We're looking north. And so our big pothole is right here. Okay, so let's set up a work zone on how to close the right lane in this situation. Speed limit is 35 miles per hour. So we're right here. So we really need to consider, especially where we place signs for an advanced warning area. It's a 3-hour project. How can we close that right lane down on this 4-lane undivided roadway? So who's going to tell me the typical application we use here first? Better watch out, it might be a trick question. But I'll give you some tricks and tips. How's that? Okay, so the closure of a right lane, you might be picking TA 33, but will it actually fit in this situation? So let's take a look at typical application 33, and we're going to install it for 35 miles per hour. So our sign spacing, if we look at that table, is 100 feet apart. It's an urban area, low speed. So A, B, and C is 100 feet. That's 300 feet that we just ate up right there, right? Then the length of the merging taper at 35 miles per hour, we look at our table real quick, is 245 feet. So before we've done anything, we've eaten up 545 feet. And if we wanted to install a buffer space, that's another 250 feet. So that's, close to 800 feet. All right. So if we wanted to be absolutely safe and install this 800-foot long advanced warning area and buffer space, let's see where that gets us. Get these boxes out of my way here. So remember, I gave you a measuring tool. With Google Maps, you can measure distances. So let's measure a distance here from approximately where the problem is back to this intersection. See what sort of, because we'd like to fit everything in before that intersection with Columbus Street. So if our work area starts here where my arrow is, then I right click and then I hit measure distance at the bottom of this box that pops up. And then the next place I click on is going to give me a distance. So if I do at the beginning of this intersection at Columbus Street, it tells me that the distance is 210 feet. And so I don't really like to install a work zone where you got to change lanes and you're dealing with an intersection. And so I would recommend a different typical application. So any ideas which one I might use? And I can clear that measurement by clicking clear measurement. But the answer that I would pick is 22. So what is 22? 22 is a right lane closure at the far side of an intersection. So let's get back to 22 real quick. That's this one. So as you can see in this picture, the work area is on the far side of the intersection in the right lane, just like we're going to be, but it's on up the street, right? But what we can do is we can set up the work zone just like this, but we would stretch this work zone with our cones or drums, either one, all the way up past where we're working. That way we don't have to worry about a taper and we don't have to worry about a buffer space because it's all taken care of with this design. So with that in mind, I would set up the advanced warning area south of Columbus Street with these signs, and then have a barricade with an arrow board here. And then all the other legs of the intersection, all they need is a road work ahead sign. But when we deal with a project that's 3 hours in length, we're supposed to use all these signs. If we were there for less than an hour or a 15-minute job, then we could get by with less. And but remember, as the manual says, if we want to get by with less signage, we have to enhance our devices for we have to have a truck with the like a utility sort of work truck with all the flashing high intensity lights, and with high volume, you could even have a truck mounted attenuator, and you can put signs up as well. But if it's like a 15-minute or less job, maybe you do that, because remember, as we learned in part 3, we showed part 3 of the course. We showed you the manual where it says in situations where it takes longer to install signs than to do the work, then you have some options to consider. But this was a 3-hour job, so it'd be quicker and easier to install the work zone like this by stretching this work zone and handling all the transitioning at the intersection. Okay. So again, we can, I thought that was pretty good, how to use Google Maps and how to lay out your intersection. So at 35 miles an hour, the advanced warning area, in this distance A, looks like there's 3 signs within that distance A, and then another 100 feet for this one. So this road work ahead sign at 35 miles an hour is located 200 feet before Columbus Street. And then in 100 more feet, you begin with the lane ends merge left, and then 2 regulatory signs that say right lane must turn right. And then you have the arrow board located right there on the far side of the intersection with the barricade, and then you use the drums. And the spacing of the drums in that situation would be at 35 miles an hour. Your maximum spacing would be 70 feet. But if you're thinking that's too far apart, you can put them closer together. So that's the maximum spacing. All right, so that's about all I got on that. Whoops. All right, let's get back to the. Okay, so what else do we have? Is it time to summarize? We got 5 minutes. So that's really all I got. We've survived part 5, it looks like. So just wanted to summarize a bit here, and what all we went over. We went over a lot of stuff in part 1 with the manual, how to find one, how to find it online as well. We went over several typical applications throughout the 5 parts. Talked about how to use the standards, guidance, and options. And anytime we're dealing with high-speed traffic or high volume or restricted sight distance, we want to include the options that are shown in each typical application, whether it be more signs or more high-intensity lights, or the arrow board, or truck-mounted attenuators. Those are all options. Or how do you, sometimes police can be used in your advanced warning area or in an intersection. We learned how to flag properly. Talked about mobile operations, and I went over some things on street closures and detours. And we got some good practice using the tables on page 17 on how to define the length of tapers and spacing of cones or drums, and how to use Google Maps to figure things out to see if things will fit, or whether maybe you should use a different typical application. So I thought it was important to go over flagging versus mobile. Just because you want to use a mobile operation on a high-speed 2-lane curvy road doesn't mean that you should. Maybe you should use flagging even if it is a quick job, just because of the more advanced warning you give the motorist in those situations. The advanced warning is so important in those situations. So I really want to thank everybody for participating in our work zone traffic control webinar series, and hopefully you learned some things and gave you maybe some tips or tricks on how to set things up. And really appreciate it. I'll be sending out your certificates for today. And as a reminder, if you think you didn't get the certificate, always check your junk mail in your email too, because I got a lot of emails about how people didn't get theirs, but I think they all went to the junk mail. So why don't you, before you call us to say you didn't get it, please check your junk mail. Maybe it's in there. So is there anything else, Paula, that we need to go over? Is there any questions or anything?
No, I don't have anything else. I will be sending a follow-up email to all the attendees with access to all of the documents that you've provided and the YouTube links so that they can review any of the 5 sections. So other than that, nothing. Thanks, Ray.
All right. Well, thank you, everybody, and we'll see you at the next webinar.
Thank you. Have a great one.
Okay. Bye-bye.